Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the first unit of microcontroller and application, which is basics of microprocessor and 8051 microcontroller. So in this video, we will study the PSW register, also called as flag register. The full form of PSW is Program Status Word Register. It has a 8-bit register, as you can see here, bit from bit 0 to bit 7. So it is a 8-bit register. Now in PSW register, there are different flags are there in this register. So we will start with the first flag, that is carry. Which is bit 7, PSW.7. It is a carry flag. Then PSW.6 is the auxiliary carry flag. Then this is the F0. It is used for a general purpose bit. And then these are the RS0 and RS1. These two bits are to select the bank register bank selection. For register bank selection, these two bits are used, that is bit RS0 and bit RS1. The next bit is the OV, that is overflow flag. This is the user defined bit, and last bit is the parity flag, that is P. So we will see the description of this flag register, PSW register. It is an 8-bit register. It contains the 4 math flags, that is carry flag, auxiliary carry flag, overflow flag and parity flag. 2 register bank selection bit, that is RS1 and RS0, and 1 user flag, that is F0. It is a bit addressable register, that means the user can set or reset the particular bit in the PSW register. So it is a bit addressable register. So we will study first carry flag. It is set or reset by the arithmetic and logical operations. That means when the carry is come out from the 7th bit, then this flag is set, and if there is no carry, then this flag is reset. Here you can see this flag is set whenever there is a carry out of from the 7th bit of the result, otherwise it is reset. In subtraction operation, if the borrow is needed by the bit 7, then carry flag is set, otherwise it is reset. It can also be set to 1 or 0 directly by instructions such as set BC, that means set particular bit which is C, carry bit. So if by using this set BC, you can directly set the carry bit from the program. Then clear C, that means it will set as 0. Set BC stand for set bit carry, and CLR C for clear carry. The next next bit is auxiliary carry bit, that is AC. If there is a carry from D3 to D4 bit during the addition or subtraction, this bit is set, otherwise it is reset. This flag is used by instructions that performed BCD, that is binary coded decimal arithmetic operation. Then F0 is a general purpose user flag. It can be set or reset by the software. Its status can be observed by the software. So the user can set or reset this particular flag. The next bit are RS0 and RS1, that is the register bank selection bits. Now these two bits are used to select one of the 4 registers from the internal RAM as shown in given table. Each of these register bank consists of 8 register, that is R0 to R7. The user can use only one bank of register at a time. By default, the bank 0 gets selected. So there are 4 banks in 8051. You can see here bank 0, bank 1, bank 2 and bank 3. Now each of these 4 bank contains of 8 register, that is from R0 to R7. So 8 register in bank 1, 8 register in bank 0, 8 register in bank 2, 8 register in bank 3. So to select a particular register from a particular bank, these two bits are used, RS0 and RS1. So the combination of these bits are, if it is 0 0, then bank 0 will be selected. If 0 1, then bank 1 will be selected. If 1 0, then bank 2 will be selected. If 1 1, then bank 3 will be selected. So for selection of a particular bank, these two bits in PSW register can be used. Now next bit is OV, that is overflow flag. This flag is set or reset by arithmetic operation. When signed result is out of the range, overflow flag is set, otherwise it is reset. In general, the carry flag is used to detect the errors in unsigned arithmetic operation. The overflow flag is only used to detect the errors in signed arithmetic operation. Next flag is parity flag, that is P flag. The parity flag reflects the number of ones in the accumulator register only. So if there are the odd number of ones in accumulator register, then the parity flag will be set, that is P is equal to 1. And if a register contains an even number of ones like 2, 4, 6, then this flag will be 0, that means this flag will be reset. So if accumulator contains odd number of ones, then parity flag will set, and if accumulator contains an even number of ones, then parity flag will be reset. So next will be the DPTR register, which is data pointer register. It is the only 16-bit register. It's used in the 8051 microcontroller. So DPTR register is made up of two 8-bit registers, that is DPH and DPL. DPH is a data pointer high and DPL is a data pointer low. So they are used to hold the 16-bit memory address during the internal and external data memory access. The value of the DPTR ranges from 0000H to FFFFH. That means the minimum value is 0000H and maximum value is FFFFH. So the DPTR is a 16-bit register, and DPTR is under control of the program instruction. In this diagram you can see the DPTR is a 16-bit register. The DPTR is a 16-bit register made up of DPH and DPL. You can use this DPH and DPL as a 8-bit register separate also, or the combination of that two register is DPTR 16-bit register. So the value after reset of DPL register is 0 0. Again value after reset of the DPH register is 0 0. Next register is PC register, that is program counter register. The PC is a 16-bit register, always points to the instructions to be fetched. The 16-bit program counter register starts the program execution and indicates the address in memory from which the next instruction is to be fetched. Immediately after this execution, the value of the program counter is incremented by 1. For this automatic increment, the program executes one instruction at a time as it is returned. PC affected by call and jump instruction. So program counter PC is a 16-bit register. It is used to point out the instruction which is to be fetched by the processor of microcontroller. Next register is stack and stack pointer register. The stack is referred as an internal RAM which is used to store the data temporarily during the program execution. 8051 has 8-bit stack pointer register. It is used to hold the internal RAM address which is known as the top of the stack. When 8051 is reset, the stack pointer is initialized to internal memory location as 07H. That means the internal location of the stack pointer is 07H. When the data is stored on the stack pointer, that is SP, is incremented by 1 before storing data on the stack. When the data is retrieved from the stack, the byte is first read from the stack and then stack pointer is decremented by 1. So here the value of the reset of the stack pointer is 07. As you can see here, it is a 8-bit register from bit 0 to bit 7, and the value of after reset is 707H. Now next register are Rn register, which is from R0 to R7 register. These are 8 general purpose register from R0 to R7 of the register bank selected using PSW register bank selection bits. Now they are used for temporary storing variables and intermediate results similar to the accumulator. Which of the register banks will be active decided by the two bits available in the PSW register. That bits are RS0 and RS1 bit. Now these are the four banks: bank 0, bank 1, bank 2 and bank 3. As you can see here, each bank contains of a 7 register from R0 to R7, and these are the memory location of that particular register. That is, from bank 0 has this 0 and 0H to 07H. The bank 1 register range from 08H to 0FH. Bank 2 range is 10H to 17H, and bank 3 has a range as 18H to 1FH. So these are the bank, 4 banks, and 4 banks contains the 8 registers. Thank you.